Welcome to my presentation. In this presentation, let us look at some application problems related to factoring trinomials of the form x squared plus bx plus c. Okay, let me draw a figure in here, and then I will explain this problem, and then we'll go solve it. Let us say we have a rectangle of this type. We have a rectangle of this type. We have an outside rectangle like that, and we have an inside rectangle like this. And if the outside rectangle dimensions are given to us, the short side dimensions are given to us as a plus 10, and if the dimensions from the inside of the rectangle to the outside of the rectangle are given to us as a over 2, and this dimension here is given to us as a over 2. Let me write this a bit more clear. This is a over 2. And similarly here, if this dimension is also a over 2, and if this dimension also is a over 2, and we do not know what this long side is, we want to go find this side. We want to find this side. And not only that, if we want to find the area of this inside region, we want to find the area of this inside region of this rectangle. Okay, so if this information is given, we want to figure out how to arrive at that information. So keeping that in mind, let us try to write something out. The area of the outside rectangle is given to us. The area of outer, let me call that as outer rectangle, is given to us as a squared plus 30x plus 200. We want to find the area of the inner rectangle. We want to find the area of inner rectangle. Inner rectangle is equal to what? So this is what we have, the area of the outer rectangle. If I were to simplify this some more, the area of outer rectangle is like this, isn't it? It is a rectangle like that, and the area is given to us in terms of a trinomial. Area is equal to a squared plus 30a, not x, 30a plus 200. One of the sides is given to us, and this side here is given to us as, a plus 10, and we want to know what, we do not know this long side. So to do that, we're going to factor the trinomial and then figure out what that side is going to be. So to do that, we're going to follow the trial and error process. Trial and error. So in the trial and error process, we want to pick two numbers, the sum of which will be equal to the middle term, and the product of the same two numbers should equal the last term. So we'll see what those numbers are going to be. If we 30, I can think about it as 10 plus 20, isn't it? 10 and 20. If I were to add 10 plus 20, that should equal to 30. So I got it in one shot. So 10 plus 20 is equal to 30. So 10 plus 20 is equal to 30. The sum of two numbers is equal to the middle term, and we got that. The product of the same two numbers should equal the last term. So let us take 10 and then multiply that by 20, and then 10 times 20 is equal to 200. That is exactly equal to the last term what we have there. So therefore, the two numbers we are looking for are 10 and 20. So let us put a small cloud around it. And what we need to do now is we want to use these two numbers and expand the middle term. So the expression we have, the trinomial we have, is a squared plus 30a plus 200, and we want to expand this middle term using these two numbers. So the way to do that is as shown here: a squared plus 10a plus 20a. 10a plus 20a is equal to 30a plus 200. So now we want to factor by grouping. If we take the first two terms and the second set of terms, we should be able to factor them. Between a squared and 10a, what is common? A is common. If I pull out a from a squared, a is left. If I pull out a from 10a, 10 is left. And then in the second set of two numbers, we have, this is 20a, not 2a. This is 20a, right? So if I pull out between 20a and 200, what is common? 20 is common, and therefore if I pull out 20 from 20a, a is left, plus if I pull out 20 from 200, what is left? 10 is left. So therefore between a times a plus 10 and 20 times a plus 10, a plus 10 is common, and therefore times what is left here? A plus 20 is left. So therefore the rectangle, the outside rectangle what we have, one of the dimensions is given to us as a plus 10. Therefore the other dimension here is equal to a plus 20. That is what this means. A plus 10 times a plus 20 is the area. The area was given to us in terms of a trinomial. When we factored it out, one of the terms was one side, another term was another side. The one side was already, the short side was already given to us as a plus 10. Therefore, when we factored it out, we can conclude then by saying that the long side is going to be equal to a plus 20. Now, since we have another rectangle inside this rectangle, I'm going to draw with another color, because since we have another rectangle inside here, and the dimensions from here to here is given to us as this is half a, and this distance is half a. So this length of this dimension of the rectangle is going to be 10, isn't it? If I were to subtract half a from there and half a from here, half a plus a half a is 1a. So if I subtract a from a plus 10, I'm left with 10. Similarly here, this dimension is also half a, and then this dimension is also half an a, like that. So therefore, what would this dimension be? This dimension here is going to be equal to, from a plus 20, if I subtract a, what is left? 20 is left. So the rectangle, the new rectangle, the inside rectangle dimensions are going to be, 10 and 20. In the problem, we wanted to know what is the area of the inside rectangle, and how do we find that area? The area of any rectangle we can find by the long side times the short side. The long side in this case is 20, and the short side in this case is is 10. This is 10. For 20 times 10. So therefore, the area of the inside rectangle is going to be equal to 200 square units. And that's the way we want to be able to solve these types of problems. And here we have used the trinomial. The area of the outside rectangle was given to us in terms of a trinomial. We wanted to find the area of the inside rectangle. We were the dimensions, the outer dimensions from the inside to the outside rectangle were given to us, and therefore when we used all of that information, we were able to find the area of the inside rectangle. And these are some of the application problems related to factoring trinomials. In my next presentation, we shall look at some more examples related to factoring trinomials.